So let's talk about the idea of verifying trigonometric identities. And the first thing to do is recall our basic identities once again. We have our reciprocal identities, ratio identities, and Pythagorean identities, which we've used in the past to simplify expressions and rewrite our trigonometric functions in order to find other values. But an identity is a little bit different. An identity equation is the kind of equation that will be true for every value of the variable in the domain of that function. In algebra, we might have stated it this way, that x plus 2, x times x plus 2 plus 3x plus 1 equals x squared plus 5x plus 1 is an identity equation because it's always true. How do we know? Well, we can rewrite one side of the equation and make it look like the other side here by multiplying, for example, x into x plus 2 through the distribution process, x squared plus 2x plus 3x plus 1 equals x squared plus 5x, and it's a little bit more obvious why now, because our like terms of 2x and 3x can be added, and so that both sides, x squared plus 5x plus 1, is equal to itself, verifying the identity. In a trigonometric identity, however, we're given a statement that's already true. Our job is to verify that statement is true by manipulating one side of the equation or the other to show that it's equivalent on both sides. Now, there are certain rules that we have to follow, and people love to, kind of play fast and loose with those rules here, but these are rules that we really have to follow if we're going to legitimately verify these identities. Rule number one, you cannot add, subtract, multiply, divide, or do any other operation to move terms or factors from one side of the equation to the other. If you're looking at this equation down here below, we can't do something like divide both sides by sine of x. That would violate this rule. Number two, we can use any algebraic operation to simplify on one side or another. So multiplication, factoring, adding like terms, combining with common denominators, and so on can be used. Then we can also use the corresponding trigonometric identity to help us rewrite one side in terms of the other. Our overall goal is to rewrite one side or the other side of the equation to make it both sides of the equation equal, thus verifying our identity. And in this example right here, we're told, let's verify that sine of x times cosine of x times tangent of x is equal to the square of the sine of x. So using our rules, we can't do anything like divide out one of these factors on the left, but what's generally done is that we can take one side that looks a little bit more complicated and perhaps rewrite it so that it becomes less complicated. So let's take this quantity right here. Sine of x, cosine of x, you notice that we have this all in terms of sine of x, and we remember that tangent of x is a quotient of sine and cosine. So let's rewrite this left-hand side and so that we now have sine of x times cosine of x times sine of x over cosine of x. And now it becomes a little bit more obvious what's going to happen in the next step right here. All right, we just want to make sure that whatever happens on the left-hand side, we get a result that looks like what's on the right-hand side. So sine of x times cosine of x times sine of x over cosine of x means that we can cancel out cosine of x, and we're left with sine of x times itself, and that should be equal to sine squared x. Well, it is, right? Because any number times itself is the square of itself, so sine squared x on the left is now equal to sine squared x on the right, and we've verified that that identity is true. And we'll note a couple of quick things right here. I use QED, which is from the Latin quod erat demonstratum, which means which was to be demonstrated. Sine squared x equals sine squared x is a true statement. And you'll notice that the only thing that we did was we manipulated the expression on the left-hand side, and we left the expression on the right-hand side completely alone. We didn't rewrite it. We didn't do anything. And typically, if we can work with just one side or the other, that's the most effective way of verifying these identities. All right, more to come.